Morning, colleagues. Welcome to SAMPE, the Society for the Advancement of Material and Process Engineering. Before we launch today's webinar, let's get better acquainted with each other. Please enter 4 items into the chat: your name, your organization, your geographic location, and the societies that you belong to, including SAMPE. My name is Raj Manchanda, and I'm the Chief Technology Officer of SAMPE North America. And Ms. Rocio Figueroa, Program Manager, Education and Technology on my team, is managing this presentation. I apologize, I don't have video today. On behalf of our CEO, Ms. Rebecca Stacha, President Sarah Cox, and the other members of the Executive Cabinet, we welcome you to the SAMPE Technical Committee's webinar on making composites circular, sustainability challenges and opportunities, featuring Dr. Lee Richardson, Global Technology Director, Advanced Composites and Engineered Fibers of Avient Corporation. SAMPE currently offers 7 technical committees, and we invite you to join a technical committee of your interest on SAMPE's 365 community platform. TC4, Recycling of Composites, produced this webinar. The TCs provide year-long education and networking opportunities for experts, early career professionals, and graduate students. They're a great way to start getting more involved with SAMPE in addition to our chapters. The technical committees typically meet virtually for approximately 1 hour each month and twice a year in person at the SAMPE Spring Conference coming up in 2024 from May 20 to 23 in sunny Long Beach, California, and CAMEX, which is fast approaching, from October 30th to November 2nd in Atlanta. The CAMEX team is pleased to report a record high of 500 exhibitors who will be showcasing their equipment and M&P industry solutions in Atlanta in just over a month. Also, please submit your abstract for SAMPE Long Beach 2024, since early demand from exhibitors is outpacing previous records, and we expect a very large turnout for SAMPE Long Beach. As mentioned earlier, please enter in your chat your name, your organization, your geographic location, and which societies you belong to, including SAMPE. SAMPE members and non-members can join a TC of their choice on SAMPE's 365 community platform. This summer, SAMPE released the State of the Technology Industry Report, which is developed by the technical committees. Please download your complimentary copy from the SAMPE online store at nasampe.org. Composites World edited the report and announced it to its global readership. Technical committees are open to global participants from industry, academia, and government, and offer a convenient platform for all to learn, network, and discuss trends and collaborate on industry solutions. Again, please join a technical committee of your choice and increase your knowledge and professional network. Now let's welcome Dr. Qiang, Vice Chair of SAMPE's Technical Committee, TC4, Recycling of Composites, who will serve as moderator for today's presentation. Zhe is an assistant professor of polymer science and engineering at the University of South Mississippi and was recently recognized as the SAMPE Young Professional of the Year. Thank you, Zhe.
Yeah, thanks, Raj, and then welcome everyone. So before we start, I just want to give 2 quick notes. The first, that this webinar will be recorded, and you should be able to receive a link afterwards, and then to see the video of the webinar. Second, if you do have questions, please type it into Q&A, and we will moderate all the questions after Lee finishes his presentation. With that, it's my great pleasure to introduce Lee Richardson today as our speaker. Lee Richardson received his bachelor degree in chemical engineering from Virginia Tech and a Ph.D. degree in chemical and biological engineering at MIT. He is Global Technology Director for Advanced Composites and Engineered Fibers at Avient Corporation, a specialty material science company focused on creating sustainable material solutions. Prior to that, Lee spent 16 years at Tubang in a number of R&D and technology leadership roles focused on high-performance fibers, composites, and sustainability, and delivering lightweight, fire protection, and other performance solutions across a variety of market segments, including aerospace, defense, emergency response, consumer goods, and hair care. From 2017 to 2020, Lee built a global cross-business circular economy startup with Tubang called Second Life Materials that delivered over 25 million of profitable innovation-driven growth by transforming manufacturing scrap and end-of-life materials across markets into new products. He remains passionate about growing a global circular economy and a more sustainable planet through collaborative innovation. With that, floor is yours, Lee.
Thank you, Joe, for the kind introduction, and good morning or afternoon, everyone, depending upon where you are. Okay, so this is the agenda that I'll be following. I'll be following today. Whoops. I'll preface this by disclaiming that what you'll hear today is really a fair amount of perspective based on my personal experiences working in fibers and composites the past couple decades, and developing and growing circular economy initiatives in this space. So this is by no means the end-all be-all playbook. And really my goals today are to lay out some of the challenges and opportunities inherent in making composites more circular, to share some examples of successes and resources that you can consider. And hopefully, ultimately I'd like to stimulate your thinking on approaches to crafting your own composite circular economy journey. Not only as individuals, but also considering how do we structure teams and organizations and establish the right mindsets to be successful in closing the loop. So before we get rolling, I'd like to understand where all of you all are coming from regarding your roles or focus in the composites industry. So please take part in our first polling question of the day. It's a pretty simple one, basically like where are you coming from? What are you representing? If it's multiple things, choose your largest focus, from a composite designer or manufacturer to raw material supplier, end user of composites. Maybe you're a recycler or a sustainability solution provider. Maybe you're in academia or government. And if none of these fit any bill for you, then certainly choose other. We'll wait and see what the distribution looks like. Okay, wow, we've got a wide swath of various backgrounds and focus. So this is great, actually. Well, I hope that everyone here can find some part of the talk that's both relevant to them and maybe learn something that'll be useful in your endeavors. So thank you for taking part in that. So this is Vernazza. It's a village in the Italian Riviera in harmony with the world around it. So diets are based on what can be grown locally and fish from the sea. You can see the village is carefully carved out of the landscape. It's perfectly integrated to serve its inhabitants while it's minimizing its footprint. Now I visited here 25 years ago, and this still strikes me as one of the most idyllic places on earth, particularly because you see human beings playing just a role, their role in a greater natural ecosystem. And for me, this is the true picture of a circular economy. I always say that circularity takes a village to be realized. And when I'm talking about that, this is the picture that sticks in my head. Now in 2017, I got the unique opportunity to create a circular economy startup from scratch within DuPont. It was really a growth experiment by the company. And to be frank, almost everyone except for me, my business partner, and our president who funded us with resources, everyone else thought it was destined to fail. I had more than one individual tell me to be sure I had something lined up in the next 6 months to jump to. Others repeatedly said, hey, there's no profitability in recycling or green endeavors, and there's no way you can be successful. So we started as two individuals drafting strategy, exploring the circular economy space. And 3 years later, we were a high performance cross-functional team of 16 that had generated $25 million of some of the most profitable revenue in the company. So the keys were dedicating technical and commercial resources solely to the effort, finding the right external partners, and also ensuring that everyone captured value. So meaning everyone in the loops that we were working within or creating benefited. So everyone has to benefit for a circular economy to be truly sustainable. Now, 2.5 years ago, I came to Avient, and I brought both my learnings from these experiences as well as my passion for sustainability and circular economy to our advanced composites and fibers businesses. For those who aren't familiar with Avient, we're an approximately $4 billion global company headquartered in Avon Lake, Ohio, with 10,000 employees and more than 115 sites globally. And over the last several years, we've transformed ourselves largely via acquisitions and divestitures from a company that was previously called Poly One before 2020 into the Avient of today, which is a diverse specialty materials company with a significantly growing portfolio in fibers and composites. Our most recent acquisition was Dyneema, ultra-high molecular weight polyethylene fibers last year, which we purchased from DSM. And it's no secret that we plan to continue growing in composites and fibers. Now sustainability is very important to us, and we live it every day at Avient. It's one of the reasons I was so excited to come to Avient in 2021. We talk about sustainability in terms of our 4 Ps: people, product, planet, and performance. And we care on a holistic level. It's not just about what we sell. In July, we just delivered our latest annual sustainability report related to our 2030 goals. And so I encourage you to check that out online to find out more about what we're doing. I'm very proud of where we're headed, the goals we have, but also the progress that we've already made in that direction. From a people standpoint, we're a great place to work certified company since 2019. Diversity and inclusion is a priority for us, and we're proud of the fact that we have 7 times the industry average in safety performance. When it comes to our products, our sustainable solutions portfolio specifically has grown over 2.5 times since we baselined it in 2016. And when it comes to the planet, we're focused on decreasing waste to landfill and greenhouse gas emissions. We're also helping our customers reduce their carbon footprints via our products that we sell, and also the innovations we're working on, not just for them, but with them. From a performance standpoint, we've demonstrated a 12% organic CAGR from 2016 to 2021 in revenue from sustainable solutions. And I'm proud to say we've been recently recognized by organizations including Newsweek and Barron's as being among the most sustainable companies. When we talk about our products and the innovations that we pursue, we refer to our 8 ways to be more sustainable. This includes reducing weight, energy use, or VOCs, which you can imagine composites is a big contributor to. That's what a lot of us are doing every day. And then renewing our resources via recycle solutions. We'll talk about some of those today, as well as the use of biopolymers. And finally, preserving our planet and our people by being more eco-conscious, delivering more sustainable infrastructure, and contributing to improved human health and safety. So when we consider a new innovation project, like we're gonna go after this, how and if it will drive sustainability among these 8 ways, it's a key deciding factor in whether or not we will pursue that innovation at all. Now, many of you in the composites realm may not be familiar with the Avient name, but you're likely familiar with a number of our brands, which represent various acquisitions made over the past decade. So we design and manufacture a variety of specialty fibers and composites in a number of different product forms, and it includes both thermoset and thermoplastic composites. So everything from long fiber thermoplastics and tapes from Plasticomp to thermoplastic tapes, laminates, and panels from Polystrand. We have thermoset laminates, shapes, and pultrusions being manufactured by Gordon Composites and glass forms, and specialty coated fibers and pultrusions from Fiberline, And then most recently, of course, our Dyneema ultra high molecular weight polyethylene fibers, tapes, and laminates. We're also able to leverage the polymers formulation expertise of Avient's specialty engineered materials and color additive and inks businesses, and our innovations that are aimed at new composite and fiber developments. So our advanced composites businesses play in a variety of markets and applications. So we're very diverse in that regard. On any given day, we might be talking about everything from boats and trucks to prosthetics to next generation shoes and apparel to ballistic protection to hydrogen, solar, and wind energy applications. We even have an Avient design arm that works directly with our partners and customers on developing or improving end user industrial design elements. So certainly, I encourage you, reach out if you envision ways that we could be a partner, a supplier, a customer, or a collaborator with you or your organization. My email address will actually be in the final slide of the presentation. So happy to entertain connecting in that way. But today we want to focus on making composites circular, and I think it's important that we baseline ourselves on what a circular economy is, what the principles of circular economy really are. So the idea of a circular economy is based on mimicking nature, which has inherent processes for renewing materials and resources. This is the well-known Ellen MacArthur Foundation butterfly diagram. On the left are bio-based renewables cascades, and on the right are means for making finite materials more renewable-like, or at least longer lived. This is where we get the adage of moving from our linear take, make, waste value chains to more circular value chains, where we create these loops that keep materials circulating and instead of wasting them without recovering value, which also depletes them from our environment over time without fully replenishing them. So for our discussion related to composites today, we focus on the right side of the diagram, and we consider the different means of creating circular loops by maintaining or prolonging materials' lives, reusing or repurposing materials, refurbishing them, or recycling them. So most people will jump straight to recycling when they hear circular economy. And I'm guessing there are plenty of folks on the call today who basically equate circular economy with recycling in their minds. In reality, it is an important part of circular economy, and it should be designed for in our material developments. But recycling often requires the most energy and resources to be successful in comparison to the other circularity means at our disposal that are represented here. So if we start with maintaining or prolonging the lives of materials and applications, that's merely designing the right materials and mechanics into our solutions. And this is something we already aim for consistently with composites. We frequently design more impact resistant or corrosion resistant materials to replace wood or metal. Think about the greatest selling point for composite rebar. Significantly longer life in a bridge or other concrete structure versus the steel rebar, which will corrode over time. Reuse or redistribution can involve repurposing something as it is, but it can frequently be a business model solution also. So leasing a product so that more users can get greater and longer use versus a single buyer only using it while they need it, that's an option as well. And then the third type of finite materials loop is refurbishing or remanufacturing. This is something we have to consider upfront in the design or development stage. So with respect to composites, designing in repairability is key, right? And we do that pretty well today if we're creating a composite part for an airplane or a boat, but we may do it less frequently in other applications where we might consider the composite a single-use material. So that's an area where we can certainly do more and be more thoughtful about. And then finally, we get to recycling, which is where we see a lot of laser-focused effort and discussion and continued innovation very, very consistently across the composites industry. And so I'll devote a fair amount to this topic the rest of the webinar. Now, when it comes to general principles and a mindset of circular economy, there's a lot of great reading out there. I listed several here that I've found useful over the years that you might follow up on. But just realize that, like me, each of these authors, has their own take. But I think you'll find that the major themes will be relatively universal when it comes to circular economy. So before we jump into more focus on composites themselves, I'd like to poll the audience once more regarding your participation in the circular economy today. So we can bring that question up. Are you or your company actively participating in or developing solutions for the circular economy today? Simple yes, no. See what's come in. Okay, this is great, actually. I'm really excited to see that. So, 83% is a strong. That's very good. I'll be honest, I didn't really know what to expect, but I was curious if people were actively doing this. So I appreciate those responses, and it's actually really exciting for me because that's something I'm passionate about, and I know we're driving it at Avient. So excellent, thank you. So when it comes to creating a circular economy, particularly recycling, and yes, now I've jumped straight to the fourth loop of recycling. Composites can be a real challenge. They're a multi-material system with an enormous variety of constituent options. When you consider all the different fibers and matrix resins in use, then you've got thermoset versus thermoplastic composites have to be considered differently. And each composite really is its own unique challenge in most instances. So composite recycling is certainly more technically challenging because of all that than today's plastic recycling approach. So when we think about dealing with the fiber reinforcements in composites, we have to consider the chemistry of the fibers, their dimensions, and their orientation in the composite. Now, across our portfolio at Avient, we process everything from glass and carbon fibers to aramid, Dyneema, LCP, nylon, and even polyester fibers. And the chemistry matters in how you can treat them in a recycling process. Also, what you will get out of that process, and then how you can create a second life for that material. I mean, I can pyrolyze a glass fiber or a carbon fiber composite, but I'm not likely to go that route with an aramid composite. Fibers can also range in length from a continuous to long or short fiber to even shorter forms like pulp in a composite. And additionally, the filament diameter varies even within a given fiber type. And that matters when you consider its possible utility in a second application. And finally, the orientation of the fibers varies from composite to composite. You can have unidirectional or bidirectional fibers, often in continuous fiber composites. And then as you get more quasi-isotropic and with many discrete fiber composites, you'll find fiber orientation to be more multi-directional or even random in nature. And so how you can repurpose or what you will get out of a recycling process will certainly vary depending on the fiber orientation and the composite you're looking to solve. And then when you consider the matrix resin of a composite, you typically have to deal with thermosets differently than thermoplastics. Thermosets are chemically cross-linked, so typically not considered reprocessable or recyclable. I'll say typically because there are some thermoset resins that have been developed or are in development that can be unzipped after being cured and maybe reformable, removable, or recyclable subsequently. So for thermoplastics, we generally consider these recyclable because you can soften, melt, and reshape them. But I will remind you that it is not trivial to effectively separate every thermoplastic resin from a given fiber and a composite. It can also be very energy intensive. So recyclable does not equal recycled. And until we've created a technical solution with viable outlets, including collection, sorting, effective recycling technologies, plus new applications, for the recovered materials, where are we going to put them? I don't consider it a circular economy solution to just claim my composite is recyclable. So what are our recycling options when it comes to composites? Now, not everyone classifies recycling technologies this way, but it's common to see two buckets. They're chemical recycling, sometimes referred to as advanced or molecular recycling, and mechanical recycling. These are classifications derived from plastics recycling. So when it comes to composites, chemical recycling is primarily referring to what is happening to the matrix resin. In pyrolysis, you're typically oxidizing the polymer matrix at temperatures in excess of 500 degrees C, and you're recovering energy and maybe some, oligomers or shorter chain molecules out of the process, plus the fibers. Whereas in solvolysis, you're reducing the chain length of matrix polymers back towards their monomers while removing the matrix from the fibers. So you can recover both the fibers and chemical products of that matrix resin more wholly. In pyrolysis, you're more likely to damage the recovered fibers and reduce their properties in subsequent cleaning steps to remove the pyrolysis char. But some composites or mixed material applications require this route. There's just not a solvolysis option dependent on the chemistries involved. Now, on the mechanical recycling side, we're not affecting the chemistry or the composition of the composite being recycled. We're merely size reducing it to a scale that we can render it effective in a second life application. So we can grind it all the way down to small particles for use as engineered fillers, or we may be able to maintain a larger scale where fibers remain of reasonable length to be used as true fiber reinforcement in their next life. And by the way, you're never limited to just one recycling route to achieve a solution. People are effectively applying both mechanical and chemical recycling technologies in efforts to recycle everything from wind blades to aircraft parts and beyond. But when figuring out what the preferred recycling strategy is for your given composite or application, you'll have to make choices, right? There's not necessarily a right or wrong, but there's a choice you'll have to make, and there are plenty of aspects to consider. How much energy is required? Are there any environmental impacts, negative or positive, to consider? Things like water usage or possible contamination issues to address. What will carbon emissions look like for the entire new life cycle versus what's being done today? What will be the value of the next life for this material, and how long can you prolong its value? Are the economics for all parties positive and sustainable? So in the next few slides, I want to share some examples of approaches we're taking across Avient's composites businesses towards circularity. In both our thermoset and thermoplastic composite manufacturing, we generate a lot of fiber waste. Glass is the largest by volume, but there are other fibers we're processing and creating waste of as well. A lot of this remains continuous glass fiber, but in the form of what we call shorts following creel changes. At the same time, our cutting, machining, and finishing processes for the composites we produce a lot of finer composite particulates we call grinds or dust. We readily collect both of these sets of materials, but they've historically gone to landfill in significant volumes. However, we have a sister business, Avient Specialty Engineered Materials, that formulates and compounds specialty resins, so including many short fiber and filler reinforced resins. So we've been working with them and their customers to transform these waste streams for us into, post-industrial recycle grade reinforcements for injection molded parts. So depending on our material source and the intended application, this might require resizing the fibers to compatibilize them with a given resin. We might have to cut them to a specific length to get the performance we need, or we may have to collect a certain fraction or stream of the composite grinds that are the right particle size or color to meet the end user's performance requirements. Now, this is all technically doable, but it also takes a commitment to managing waste streams like we manage our first grade products, which is not something that most people are focused on. Historically, we are now. We've also been successful at repurposing our composite waste into new and very different applications without having to change the material form via a recycling process. So we've been able to sell a significant volume of off-quality thermoset pultrusions that would otherwise go to landfill to customers who use them as fence posts. So a whole different application from markets we're serving, but they have value for these materials. And so that's a great example of repurposing and not having to put a lot of energy into reforming a product. And as I mentioned before, recyclable does not equal recycled. So we have dedicated ourselves to not just being a generator of composite recyclate, but to being an outlet for employing recycled content in our composite products. So a couple examples. On the left is our recycled polyester composite laminate product that incorporates up to 95% post-consumer recycled polyester as the matrix resin, and it significantly reduces the overall carbon footprint versus virgin PET resin, laminates that we would produce. Similarly, on the right, we use post-consumer recycled nylon 6 from fishing nets and post-industrial recycled nylon 6/6 and TPU and 3 different recycled content LFT products that we've commercialized. The key is that we start our product development process with the end in mind of incorporating recycled content where possible. And so over time, we've also, through this process, we've developed the capability to assess and certify cradle to gate carbon footprints of our products to include our own scope 1 and 2 emissions, as well as upstream scope 3 emissions of our supply chain. I believe this is an important capability to build in order to quantify the impacts of circularity efforts and to be able to make the most sustainable choices in the future. So encourage everyone to make that part of your long-term journey. And so as I close the discussion on recycling composites, I'll point you to a great ACMA resource listing U.S. companies developing and employing various composite recycling technologies. I think this is a great starting point if you're exploring composite recycling options, but there are plenty of others out there globally as well that are doing this, and new technologies are being developed and scaled every day. So what if you can't recycle your composite? Is it better to just send it to a landfill, or should you consider waste to energy options? Now, frankly, this can be a polarizing topic, and I'll admit it's not the answer for all situations. But I am a proponent for waste to energy, typically being a preferred route over simply landfilling. When you landfill material, you recover no more value from it. Plus, methane is liberated in landfills, which is 25 times more potent as a greenhouse gas than CO2. So when you convert waste to energy, you do recover the energy value of the material. You also displace fossil fuels that would otherwise enter that process. And in some cases, you can, select materials may be recovered from waste to energy processes. But also, carbon capture options are being developed and invested in heavily. There's recent large government investment and continuing to develop carbon capture options. So I view in the future that waste to energy processes should become even more sustainable with carbon capture options being developed. But in the end, waste to energy shouldn't and cannot become a catch-all or a crutch for us not to go find better solutions, but it can be a better destination than landfill for materials that we just haven't been able to figure out yet ways to repurpose or recycle. So we've discussed a lot of the technical challenges and options for making composites circular. There are a number of hurdles on the business or commercial side as well. So collection and sorting in economically viable ways can be more challenging for composites than today's consumer recyclables collection models, because those are already relatively well established with infrastructure in place. Even if they're not always extremely efficient, a recycling truck picks up my household recyclables curbside once a week. But how do we collect composites from a boat or a car or a building at their end of life? So establishing partnerships with regional parties and ensuring they can operate viably is difficult, but it's necessary if we're ever going to accomplish our circular vision for composites at scale. And achieving consumer and end user buy-in to participate is also critical. There are lots of models that you can consider, including buying back valuable composite materials or convincing end users to return them at their own expense, or sharing the costs, right? Leasing products can also establish an inherent model of returning composites that can be deployed elsewhere for longer lives. Yeah, but sometimes we also have to ask ourselves if a collection and recycling model makes sense. So for wind turbine blades, when does it become less sustainable to transport enormous blades around, break them down, and employ recycling technologies and all the energy associated with that versus simply landfilling them? And now, for the record, I am a proponent of figuring out a circular solution. And I know we had some discussion on this in a previous webinar, but also we have to be objective about that and about any circularity challenge that we're trying to solve as we consider down the road. So at the end of the day, circularity requires significant collaboration among many parties, and playing well with each other isn't always the easiest thing for big companies and small companies and everything in between. But every party in a loop needs to receive value, or the loop isn't sustainable. In a functioning loop, each party provides a valued service to their customer as well as to their supplier. As businesses, we're often focused on maximizing the value that we capture or obtain in a relationship. But there's a slippery slope between maximizing value and grabbing a disproportionate share. So if we each ensure that our suppliers and our customers in a circular value chain like this are receiving value as we are, then the loop will flourish and everyone wins in the end. Now, in the last few minutes, I want to flip the script when it comes to composites and circularity. So we've been talking here about how the combination and the multitude of materials in composites makes it impossible to find a one-size-fits-all circular solution for them, and it creates plenty of technical challenges for recycling or repurposing them. However, if we consider how we design so many different composites and the plethora of markets and applications that they go into, this really creates an endless palette and a canvas upon which we can create new composite artwork per se from composite waste and end-of-life materials. So let me tell you what I mean. Consider first your composite palette, the various fibers and the resins that you can choose from and creating a new composite. Now, if you add in recycled forms of all these fibers and resins to these lists you see, and then you start considering all the new combinations you can generate with a range of virgin fibers and recycled fibers and resins alike, voila, you've got an endless number of new composites that you can now create. And then consider all the markets and applications that composites go into today. So we often talk about upcycling versus downcycling materials versus creating truly circular loops by recycling materials back into the same applications. For me, all those are viable options, but there's significant power and really endless opportunity in having so many different markets and applications that can serve as the next lives for the new composites you design from the old. So don't limit your thinking, with when you really have the entire world as your canvas and where the next life of a new composite can be. And so plenty of people have successfully taken one composite and put it into another composite in a whole different market or application as a second life. I think about recycled aerospace carbon fibers going into laptop cases and automotive parts, among other things. Reclaimed aramid fiber waste goes into brake pads and high temperature gaskets and truck bed liners. And I mean, the list can go on and on of success stories. Just don't limit your thinking. And we use this graph in Avient to describe the relative ranges of performance versus design flexibility of the different composites in our portfolio. Having ranges of performance and design flexibility, including cost, offers the greatest probability of delivering the right composite solution for an application. And in terms of circularity, a next life for those materials. So it's really our means of tailoring the next unique composite work of art, given the broad palette of fibers and resins that we have and the canvas of markets and applications at our disposal. And finally, I'd like to close on the topic of organizational mindset. So what does it take for individuals, teams, and entire organizations to successfully advance and participate in a composite circular economy? So first, it requires dedicated resources and investment. I mean, you can't have people or teams tasked with circular economy efforts as a nice to have on the side of their regular day jobs. They need to be dedicated with clear objectives, invested in with the right resources, and then held accountable to achieving milestones like we expect on any growth project we pursue. This was a key to my team's circular economy success at DuPont, and one of the first things I did at Avient was to establish a formal circular economy of composites R&D initiative, with a project leader and team members that were clearly assigned to its efforts as part of their objectives. Second, and just as critical, is to focus on external collaborations to build the loops, both upstream and downstream. We must eliminate the not invented here mentality, which it often plagues larger organizations. No one organization has all the answers or all the capabilities to make a circular economy successful. And it takes a concerted effort with your collaborators. You have to strike this balance of holding each other accountable while also helping each other succeed. Be willing to start small, learn along the way, and grow your impact over time. Start with post-industrial recycled materials, your own manufacturing waste that you know really well, and then apply your learnings from successes in that regard to take on your customers' waste and eventually, end of life and post-consumer recycled materials. And then finally, aim for progress, not perfection. There is no perfect sustainability solution out there. All options have advantages and disadvantages, trade-offs that you're going to have to make. My measuring stick is, will the new approach be more sustainable and better than what we're doing today? And so if we keep making progress in that regard, one day we'll look back and really be amazed at how far we've come in closing the loop. And so with that, I'll thank you, and I'll again, encourage you, please reach out to connect. Certainly, if you have ideas how we can work together, we are big on all the things I said here today: external collaboration across, with Avient. And so happy to field any questions or comments that you might have for further discussion in the chat or in the Q&A section. Turn it back over to you, Jia.
All right, thanks so much, Lee. It was a great talk, and it was really nice to learn the opportunities and challenge towards the circular economy for composites and things beyond that, I guess. So for people who have questions, please feel free to type it into the Q&A, and I will pick up questions and ask that to Lee. I guess the first question, I will make it a bit broad, but when I try to think about recycling plastics, there are always a CO2 input or carbon emission input and the cost input, right? And how you can actually design an approach to integrate and think about both perspective and then eventually optimize system rather than just focus on one versus the other.
Yeah, and that was that was a point. One of my points about there isn't really a perfect solution, and there are lots of options out there, right? When it comes to recycling paths that you can take as an example, or whether or not you even recycle, right? And so I think you have to balance those metrics. You might really reduce carbon emissions with one route, but maybe the process uses a ton of water, right? And so then the answer isn't always black and white, like yes, I need to go this route, and that's why you really have to make choices. But part of what's important there is being able to not only develop in-house, but have access to the ability to quantify, right, those different possibilities from carbon emissions to energy usage to water usage and things. So just be mindful that you don't have to do that alone, that those resources exist out there, and so tap into them in the network that's out there, but try to be quantitative in your approach, and then make the choice that makes sense for you, your company, and your partners, by the way. So
yeah, sure. And the other question I have here is, in general, repurposing the plastic to different applications, great, but in general, people always believe that the composite materials, especially thermoset, are inherently non-recyclable, right? And you've been talking about different approaches like pyrolysis and things like this. But the question here is that what's your thought about addressing these challenges, but also moving forward? I know a lot of groups working on like a recyclable or reprocessable thermoset, things like this. How long is it going to take from a lab to a market perspective? Is that something feasible in the near future, or what's the strategy to address this inherent non-recyclable composite materials?
I mean, I think I think we're closer than you think. I think the technology is certainly there, at even at different scales. I mean, I'm aware of people having, on a commercial scale, thermosets that you can effectively, I'm calling it unzipping, but you can basically remold them, right? And reform them, and possibly even separate them from fibers. And that means, it really, like anything, economics will often get in the way of when will determine when you're going to adopt something, because at the end of the day, if it costs 5 times as much, people aren't going to sign up for that unless it's like driven by regulation or there's a requirement, right, to use it. So I think it will take time. I think we also need help from, you can't just rely on industry to adopt this out of the goodness of their heart, adopt these new technologies out of the goodness of their heart. You need to promote partnerships between industry and academia who are developing some of these solutions. And you honestly, you need legislation to help drive us towards that. We can talk about how fast you have to go towards a new solution like that, but I think all those will. My view, I see that happening. All those things happening more frequently now. I see the funding and investment from governments, both Europe, the U.S., globally, driving us toward that. I'm an internal optimist, but I'm pretty optimistic about where we're headed in that regard.
Oh, great. It's encouraging to hear that. Another great question here is that, we talk a lot about industrial decarbonization, and then, of course, establishing circular economy or material circularity is one part of it. But at the same time, can you talk a little bit about the strategy that industry should think about regarding with decarbonization of energy and process heat and towards a collective, more sustainable future?
So maybe you're talking about just what industry should be thinking about with regards to decarbonization.
I guess, in general, maybe from a more like a process perspective, right? Not just from a material perspective. Is there an opportunity or company looking into these opportunities, make the recycling process more energy efficient and more carbon friendly?
Absolutely. I mean, there's a lot of ways to go about this, right? And there's not one solution for all of it. But I mean, one thing is, right, in investing in renewable energy sources, right, for your processes. I mean, so that's a key one. I know we're focused in our own goals on transition and making that transition, and we're already doing that. And so, by the way, that can be circular as well, because I think a lot of the renewable energy technologies that are taking off or poised to take off, they're relying on, or they can get better with our own composite materials. So, we can be a part of the solution of making renewables, more cost effective, and also, a great way to decarbonize our own processes, right? I don't know that maybe that's just one route that we can focus on.
Yeah, that's great to hear too. Another question here is that, what do you think about the role of simulation tools? I guess in general, like computational power that can play with the developing circular economy for composites material, from simulation or even like AI and machine learning perspective.
Great question. Kind of two questions in one. So from just purely a simulation standpoint, I think we have a lot of modeling tools that we'll employ, particularly with composites, just to find, historically, right, that's useful in finding the right fiber and resin combinations and orientations and everything else to achieve the performance you're looking for. But I think we can also employ those same tools when designing composites from recycled content, right? So I think that'll help direct us. So, I talked about the broad palette of materials that you can use, including recycled materials, and then the canvas of applications and markets. So I think simulation, we can't trial and error, create these new materials all one at a time. So I think simulation will play a key in that. And then when it comes to artificial intelligence and machine learning, there is just so much. There's a lot of experiential information from decades of work in the composites industry out there, more than any human being can certainly consume. And so I think AI and machine learning gives us tools to really, direct us much more quickly to the right circular economy solutions. I mean, your earlier question about, how do you choose which recycling route to take based on, all the different aspects of how sustainable it is. I mean, that's a great challenge to employ AI or machine learning to arrive at maybe a preferred solution or a preferred set of solutions.
Yeah, I agree with that. I think that's a very informative answer. And I think this is another great question, because we talk a lot about circular economy, but of course, one thing that it has been really important is from the role of community. So do you have any, recommendation for, I guess, companies or academia people, how we're going to actually do the outreach or do a lot of educational activity to help, younger generations or other generations to really pick up the concept of circular economy and things like this? Any strategy, any suggestion to share?
Yeah, I mean, I'll take, an example from some things we do at Avient as an example. again, the communities, so that in the communities that we work in, right, we have information sessions where, and in some cases, even bring in family members of our workers, right, to talk about, like, all the products and where they go. Like, we're a manufacturer, but it's sometimes useful for people to see, where do your products go? And a big element of that for us is sustainability. So I think that's an area, and I think it has, I think it has to be sort of a grassroots effort for everyone in their own communities. But I think that's great. And then on the, how do we, so maybe I'll stop there on that one. But I think it, and then again, you want to contribute to your community's well-being. So we're, for us, it's United Way. We're a big contributor to United Way across the Avient Corporation, and all of that, goes back to the local communities where those various contributions are made. So these are ways that we can certainly do that in our companies and as individuals in the community.
Yeah. And I guess build up on that, what's your thought about the collaboration, cohesive efforts between like industrial, academia, and community to really strategically tackle these opportunities together? Like
that is absolutely critical. And I will say, so I view, I'm in industry, right? But I'm looking, for academia and even in some case, government to help develop the next technologies of the future. I can't, the old model of doing all that within a company, I don't think it's gone, right? So I'm looking for the next generation of technologies to come out of that, and then on the flip side, I want to help. How do we scale those, right? And so I'll take, I'll put the Remade Institute as a perfect example. I think that's one where you're bringing together, government is funding this. They're bringing together experts from academia and relevant industry partners, and what comes out of it is wonderful. So we just need more of that. And then, yeah, that's probably a good example of how we can do that. But again, we are participating where we can, and as partners with academia and even with government labs, and some funded types of attempts at R&D. So this is how I think we create disruptive technologies for the future, not just incremental advances, right?
Yeah, right, totally. And I think there's a couple of questions that ask quite similar things, I guess. Is it possible to repurpose the out of spec materials to new applications, or and then maybe you can give some examples that you have been working on to address this particular need?
Yeah. That was, the one I did give was about repurposing out of spec, protrusions into fence post applications. Those are things that, each one of them tends to be very, very focused, right? And you have to have an effort that someone says, okay, I've got, this volume of material that's in this form, and you have to have creative people that can really connect the dots and say, today this goes into this application. You have to think more broadly and really, and you, by the way, you have to go out and sort of scour the landscape oftentimes, right? We had another example where we had a carbon fiber composite that was, it was part of a development program, and we generated all this material, and some of it was out of spec, and some of it, the customer ultimately didn't take. And so, a member of our team called up someone in their network, and they said, yeah, we'll take a look at this. And, by the end, this was going into a flooring application, right? Nothing to do with where it was originally intended, but people, they found a way to take that material as it was and put it in a whole new application. You really need creativity, and you need people kind of connecting, I would say, dissimilar dots, right?
Yeah. And I guess there has been a lot of great success and successful stories over these material technology innovation. But I guess, what was one of the biggest challenges, and how did you overcome those challenges?
I'll talk. I mentioned another example where we're we're taking glass fiber waste and composite grind waste and trying to put it into an injection molded parts, right? And each one of those customers or applications is really a unique challenge. So you have to go into it. So as an example, we had these grinds, composite grinds that we were trying to put into an injection molded part. It's really easy to make something like if it's got to be a black part, you can put anything into that, right? You can make something black. But if it has to be a light or a bright colored part, right? Which in this, there was a case, where we had to do that. You can't just, you can't get to, let's say a yellow part with, gray composite dust. So what we were able to do was actually find another source in our manufacturing where we could actually collect just, white, light colored grinds. And it turns out then we could color that to the specification of the customer. So that's one thing. The other thing is we found that, if you need a certain particle size, you got to go figure out how do I collect that specific, or at least separate out that specific particle size. So there's there's a lot of that. And then I've talked about the sizing fibers. So we take these fibers, some of them were destined for a thermoset, some of them for thermoplastics. And so they have different chemistries on the surface of the glass fibers, right, to make them compatible. They may not be compatible with, a nylon or a polyester resin that you're trying to aim for, right? And so then you have to work. And again, we don't do all this ourselves. We find the right partners to help us with the capability to resize the fibers for that specific application.
Yeah, and one thing that I think different between composite in general versus commodity plastic is that composite typically came from a pretty clean feedstock or sourcing. And is that something you think is an advantage for recycling composite, even though they are not that easy to recycle compared to polyolefin materials? But the feedstock is a little bit better in terms of the recycling perspective, right?
It's a good point. I mean, obviously, and it depends on where those plastics are going. But you're right. They're composites oftentimes have sort of require, right, that your feedstocks are a little bit narrower and their properties and performance, and that can be. But again, I will say it's. So the solution may not always be separating. It shouldn't always be separating those, the resins from the fibers, as an example, because those processes inherently, introduce contaminants, right? So it's not simple, but I do think so where you can, I'm a proponent of where you can keep the composite intact and figure out how to employ that fiber and that resin together into a new application.
Great. And we're already 12:03 now, and I saw there's a few more specific questions. So if you do have these specific questions, feel free to reach out to Lee. And you show your email address on last slide, right? So yeah, that's great. So feel free to send email and things like this. Thanks, everyone.